Picture this. You send a message into the void, and it takes an entire day just to reach its destination. Not because the message is slow, but because the distance is so unimaginably vast that even light itself needs 24 hours to cross it. This is the reality NASA will face in November 2026, when Voyager 1 becomes the first human-made object to reach one light day from Earth. Today, we're exploring this extraordinary milestone and what it means for our understanding of the cosmos. In late 2026, Voyager 1 will reach a distance of 16.1 billion miles from Earth, marking the historic moment when radio signals take exactly 24 hours to travel between our planet and the spacecraft. To put this in perspective, a light day might sound small compared to the famous light year, but it represents something profound, the edge of practical real-time communication with our technology. Currently traveling at around 11 miles per second, Voyager 1 adds approximately 3.5 astronomical units to its distance every year. That's like adding 3.5 Earth-soon distances annually to its already staggering journey. Launched on September 5th, 1977, Voyager 1's original mission was to explore Jupiter. Nobody expected it would still be operational nearly 5 decades later, pioneering interstellar exploration. The spacecraft crossed into interstellar space on August 25th, 2012, becoming the first human-made object to venture beyond the sun's protective bubble of charged particles and magnetic fields. But what makes this light day milestone particularly fascinating is the communication challenge it creates. Any command sent to Voyager 1 will take a full day to arrive, followed by another day for confirmation to return to Earth. Mission controllers must plan every interaction 2 days in advance. Imagine troubleshooting a computer problem with a 48-hour delay between each attempt. The concept of measuring cosmic distances in light time reveals the true scale of our universe. During the Apollo missions, there was a 2.6-second delay between astronauts on the moon and mission control, caused by the 1.3 seconds it takes for radio signals to travel that distance. Mars can create delays of up to 4 minutes, while Jupiter extends that to 52 minutes. Voyager 1's upcoming milestone puts it in a category typically reserved for measuring distances between stars. To reach our closest star, Proxima Centauri, would require over 4 years of travel at light speed, showing just how vast even our local cosmic neighborhood truly is. Voyager 1's 4 functioning instruments continue studying plasma waves, magnetic fields, and particles in the previously unexplored interstellar medium. The data has revealed surprising insights about the boundary between our solar system and interstellar space. Scientists discovered that the interstellar medium is far more influenced by our sun than previously thought, with cosmic rays behaving differently depending on their orientation to solar magnetic fields. This challenges fundamental assumptions about how cosmic radiation affects our solar system. In 2021, Voyager 1 achieved the first continuous measurements of material density in interstellar space and detected actual sounds from the interstellar medium for the first time. These acoustic signatures help scientists understand the structure and behavior of space between the stars. The fact that Voyager 1 continues operating after nearly 5 decades represents an extraordinary engineering achievement. Each spacecraft weighs about 733 kilograms and carries 105 kilograms of scientific instruments, powered by radioisotope thermoelectric generators that convert heat from decaying plutonium into electricity. The spacecraft has survived multiple technical challenges, including a serious communication failure in 2023 caused by corrupted memory that NASA engineers ingeniously resolved by creating new software to work around the damaged components. Despite traveling for nearly 50 years, Voyager 1 remains extraordinarily close to home in galactic terms. The spacecraft won't encounter another star for approximately 40,000 years, when it will pass within 1.7 light-years of Gliese 445, an M-type star currently about 17,000 light-years away. This timeline emphasizes a humbling reality. Space is so vast that even our most ambitious exploration efforts barely scratch the surface of what's out there. Yet each mile Voyager 1 travels expands the boundary of human presence in the universe. Voyager 1 carries the famous Golden Record, a time capsule containing sounds, music, and greetings from Earth, representing humanity to any future civilization that might encounter it. As the spacecraft drifts deeper into interstellar space, it becomes not just a scientific instrument, but an ambassador of human curiosity and achievement. The Light Day milestone offers crucial lessons for future interstellar missions. NASA has implemented revised power management plans as the spacecraft's plutonium power source gradually weakens, with useful operations expected to continue. Into the 2030s, future deep space missions will need to address power, communication, and autonomy challenges on even grander scales. Voyager 1 is heading toward the constellation Ophiuchus and will eventually reach the outer boundary of the Oort cloud in many thousands of years long. After it stops communicating with Earth, its journey will continue for potentially millions of years, carrying humanity's message through the galaxy. Scientists describe the Voyager missions as providing tantalizing glimpses of a region that lies nearly out of our reach. Exactly the type of data that raises more questions than answers. Each discovery opens new mysteries about the structure of our cosmic neighborhood. November 2026 will mark more than just a distance record. It represents humanity's first tentative step into a realm where the normal rules of communication and control break down, where patience must be measured in days rather than seconds, and where every piece of data transmitted across the cosmic void carries extraordinary value. Voyager 1's approach to one light-day distance stands as a testament to human curiosity, engineering excellence, and our irrepressible drive to explore the unknown. As this tiny spacecraft continues its eternal journey, it reminds us that sometimes the most profound discoveries come not from destinations reached, but from the courage to keep traveling into the infinite darkness. What messages would you send to the stars, knowing they might take decades, centuries, or millennia to reach their destination? Voyager 1 has already begun answering that question for all of humanity.